Hi class, today we're going to learn about section 1.2 linear measure. This goes along with standard 2. Our two objectives that will be covered in this video is how to calculate line segment length, and objective 2 will be to write and solve algebraic equations using betweenness of points. So this first concept should seem pretty familiar to you. We're just going to talk about how to find the length of a segment using a ruler. So a line segment is a line that has two endpoints and can be measured. There's a difference between a line and a line segment. A line goes on forever and ever and ever. A line segment is just a portion of that line, and you can actually measure how long it is. Find the length of segment AB. Notice that there are not arrows on the end of this. There are dots. That's what makes it a line segment. So you would put up your ruler. If you're looking at inches, this is going to be 1 1/4. The fourth is right here. And if you're looking at centimeters, it's 2 lines past the 3, so it's 3.2 centimeters. Whenever you're looking at centimeters, you can use decimal points. Whenever you're looking at inches, you need to do fractions. Alright, so we're looking at centimeters for this one. What is the length of AB? Well, we're past the 1 mark, and then it's 1, 2, 3, 4, 5, 6, 7, 8. So this is 18 millimeters. I can't put 1.8 centimeters because that's not a choice here. This says millimeters. So each of these little lines is a millimeter. So here's 10 millimeters, then you have 8 more. Find the length of ON. Well, this is in centimeters. I can see that it's 2 centimeters, and 2 centimeters is an option, so that's my answer. Find the length of AZ. This is in inches. It's 1 inch, and then another half. So it's 1 1/2 inches. So the measuring should be something you've done before. I just wanted to jog your memory on how to find the measurement of segments. Now we're going to talk about congruent segments. Congruent segments are segments with the same length. This symbol right here is the congruent symbol. It's an equal sign with a little squiggly on the top. We will use this symbol all the time in geometry, so imprint it in your brain. Is line segment AB congruent to line segment BC? Well, let's remember what congruent means. It means that they're the same length. So we're trying to see if AB is the same length as BC. Well, how do you get from 3 to 8? That's 5. And from 8 to 13 is 5. So if you do the math, AB and BC are both 5, which means that yes, they are congruent. In geometry, sometimes pictures can be deceiving, so don't just go by the way it looks, actually do the math. Notation is extremely important in geometry. This is read as segment AB is congruent to segment BC. Whenever you get rid of the line on the top, that's when you're talking about length. So this would be the length of AB is equal to the length of BC. Just keep that in your mind that these two are slightly different. Now let's talk about how to add and subtract segments. We're going to be talking about an equation that's called the betweenness of points equation. You can find the length of a segment, for example, segment AC, by adding together the two smaller segments. So AB plus BC equals AC. This is the equation representing it right here. Find the length of AC. So we're trying to find the length of this whole segment. We can do that by adding together the two smaller segments. I know that AB plus BC is going to equal AC. It's going to equal that whole segment. So then I plug in what I know. I know AB is 13 and BC is 6 because it's labeled that way. Then you do your addition and you get 19 is equal to AC. You probably could have done that in your head, but I'm just showing you how to write it out because it's not always going to be this simple. The next one says find the length of AB, this segment, if AC is 22. So first we're going to write our betweenness of points equation. This is also called segment addition. I know that AB plus BC equals AC. We're going to plug in what we know. We know that BC is 10 and AC is 22. Then to find AB, you just need to subtract the 10 over. So AB is going to equal 12. 12 plus 10 equals 22. So go ahead and try this example. Find BD. Well, to find the length of the whole segment, you have to add together the two smaller segments. So 16.8 millimeters plus 50.4 millimeters is 67.2 millimeters. Now what we're going to do is throw in some variables. This we'll have to write an equation and solve it. So if DF is 50, if the whole thing's 50, find the value of x. So let's write our segment addition equation. I know that DE plus EF equals DF. I'm going to plug in what I know. DE is 2x minus 8. EF is 3x minus 2. And DF is 50. Now I just need to solve this equation for x. I'm going to combine my like terms. 2x plus 3x is 5x. Negative 8 plus negative 2 is negative 10 is equal to 50. Then we add the 10 over and we get 5x is equal to 60. And finally you divide by 5 and get x is equal to 12. Alright, the next one says solve for c and yz if y is between x and z. And then it tells you what xy, yz, and xz what their measures are. If you do not have a picture, you have to draw a picture. You need to get in this routine now because it will really help you out in geometry. So first we're going to draw a picture where y is between x and z. So point y is between points x and z. Then we're going to label what we know. X, y is 11, and yz is 4c, and then this whole thing is 83. Now we can write our segment addition equation. Xy plus yz equals xz. Plug in what we know. 11 plus 4c equals 83. And then now I just need to solve for c. I'm going to subtract 11, divide by 4, and you'll get that c is 18. The question also asks for yz. To get that yz is 72, you need to take 18 and plug it in for c in your yz expression. So 4 times 18 is 72. So that's how we got that yz was 72. That's all for this lesson. Have a great day.